Morning all. This is Suresh, lecturer in computer engineering, Government Polytechnic Masab. I am dealing with this oops through C++ subject with code 18CM402C. In the today's class, I will discuss the fifth chapter, that is about all about inheritance. So in this we have different topics like what is the necessity of inheritance, and what is inheritance, what are the advantages of inheritance, and after that we will discuss what is base class, what is derived class, and what is the relationship between this base class and derived class, and what is the syntax for defining a derived class. All this we will see in the today's class. So let us consider the first one, what is the necessity of inheritance. Okay, so inheritance is the process of creating a new class called derived class from the existing class called base class. So what is inheritance? Inheritance is the process of creating a new class called derived class from the existing class. So we already have the base class. Okay. So from this base class, if I want to derive another class, that is your derived class, this concept is called inheritance. The derived class inherits all the capabilities of the base class but can add properties of its own. Okay. So derived class can inherit all the properties. What are the properties inside the class? I can have data members and member functions. Both these data members and member functions are inherited into the derived class, and as well as this derived class can have its own data members and member functions. So the base class remains unchanged by this process. Whatever the data members or member functions that are there in the base class, those are not changed. Only thing is, I am deriving the whatever the properties that are there in the base class, those will be derived into the derived class. The derived class may override some or all properties of the base class. It can override or it can take all the properties of this base class into the derived class. Inheritance is very similar to parent-child relationship. In the general terms, if I consider the normal parent-child relationship, in which the child always gets some of the properties from the parents. Either he may get the properties from the father or he may get the properties from the mother. In the same manner, one class is there. This is your base class from which some of the properties are derived into the derived class. So any class can be of base class. We can have any class which will be acting as a base class. More than one class can be derived from the base class. From this base class, I can derive more than one class. So based on that one, we have different types of inheritance that we will see later. But derived class can be of base class to another. Okay. So what we have one base class. It is like if you have a base class, from a single base class, I can derive any number of derived classes. Like we have this A is the base class. From this A base class, I can derive any number of uh, derived classes like B, C, D. Okay, this is the base class. Only one base class is there. That is your A. From this class, I am deriving multiple classes, and in the same way, after deriving some class from this derived class also, I can derive some more derived sub derived classes. Okay, this is your base class. From this base classes, I can derive single class or I can derive more than one class, and after that from the derived class also I can derive some more derived classes. This is based on this type, we have different types of inheritances. For example, a programmer can create a base class named fruit. Okay, some programmer created a name he created a. I will see. I will show with example. So one class is derived, that is your fruit class. He created one class called fruit class, and after this, and he can derive some other classes like mango, orange, banana. Actually these are the objects, but for example, if I consider, I can derive mango. Okay, so this mango, which is derived from this fruit class. Okay, I can derive from this fruit class. Generally it is not a good practice, but I can derive like this. Mango is a class that is derived from this fruit class, and orange is a class that is derived from this banana class. Has all the features of this base class fruit with additional attributes or features specific to the newly created derived classes. Okay. So mango would have its own defined features, orange would have its own defined feature, banana would have its own defined features, etc. We will see with another example. So we will have a like if I take an example, like we have this vehicle class. We have a class called vehicle class. So I will first erase uh, so if I have a vehicle class, so from this vehicle class I am deriving two more classes, like two wheeler. Two wheeler is a subclass of this vehicle, and three wheeler, and from this three wheeler we have this four wheeler. Okay. So from this vehicle class I am deriving three more subclasses. This is the two wheeler subclass, and this is three wheeler subclass and four wheeler subclass. So that's why this for this vehicle we have some properties, like what is the name of the vehicle. Okay. Name of the vehicle, what is the color of the vehicle, how much mileage it will give, what is the chassis number. Okay, different, we have different things for this vehicle properties, and what are the functionalities that I can do by using this vehicle. I can drive. Okay. For example, if I take this functionality, this is your behavior, so that is your, so what are the different if I take a class vehicle, like class vehicle class is there. From this vehicle class, okay, so I have different properties for the vehicle class, like int what is the name of the vehicle, character name, and the next one is what is the name of the company. These are the common properties, right? So all these are the common properties for every vehicle, like how many wheels are there. Okay, int number of wheels. Okay, number of wheels. In the same manner, what is the color. Okay, so what is the color, so that may be color of the vehicle. So like this I can have. And what is the functionality, that is why drive. I can drive, or I can stop. Okay, stop. These are the functionalities of a vehicle. Okay, all this just for example I am considering. So this is your name of the vehicle, and this is your company of the vehicle. Okay, all these are the properties. From this vehicle class I am deriving subclass, that is what is the subclass for this vehicle. I can derive two wheeler, or I can derive three wheeler, or I can derive what is another class, four wheeler class. Okay, these three classes are derived from this vehicle class, so that what a two wheeler class can also having its own name and its own company and its own number of wheels and color, and three wheeler also having this properties. All the properties are derived, and it can have its own properties. Okay, so that is about introduction to this inheritance. Okay, so what is the use of this inheritance? Okay, what is the necessity of this inheritance, we will see in this. Okay, so one of the key benefits, so what is the uses of inheritance, or what are the advantages of inheritance, what is the necessity of inheritance. So one of the key benefits of this inheritance is to minimize the amount of duplicate code in an application by sharing common code amongst several subclasses. So this is the main advantage of this inheritance. So no need of already we have existing class with some code, what are the data members it may have, and what are the functionalities it can perform. So for the functionalities also I can write some code. So after, if I want to create a similar type of classes, then no need to write this class from scratch. I can reuse that class. So whatever the code that is there, that I can easily reuse in another class also. So where equivalent code exists in two related classes, so if two or more classes are having the same similar features, and they can use that similar kind of properties, then I can make those classes as hierarchical manner. Like we have the base class, from this base class we can derive subclasses, so that subclasses can inherit some of the properties from the base class. The hierarchy can usually be refactored to move the common code up to a mutual superclass. This also tends to result in a better organization of code and smaller, simpler compilation units. This is one of the advantage. And another advantage, Like inheritance can also make application code more flexible to change, because classes that inherit from a common superclass can be used interchangeably. Okay, so it is more flexible if the return type of the method is superclass. Okay, so this is also making the code to be flexible, so that one class can inherit the uh, um, common code from the superclass. Okay, and reusability. So the most common use of this inheritance is reusable. I can reuse the code, existing code. Okay, so it provides the facility to use public methods of the base class without rewriting them, but I can use only the public. Okay, there is some visibility mode is there. If one class is deriving by another class, then what are the properties that I can get if I mention the by using the access specifiers. Okay, I can whether I can access publicly, or whether I can access privately, or whether I can access protectedly, so that what are the members that are there in the base class can be derived into the derived class. That can be decided by using the visibility. But what is the main advantage of this inheritance is I can reuse those existing features in the derived class. And extensibility, extending the functionality of base class logic as per business logic of the derived class. Already we have, this is the one more advantage of inheritance, extensibility. Okay, I can easily reuse the existing functionality, and also I can extend it. Okay, I can it is like we have a base class. From this base class I am deriving one more class called derived class, so that whatever the features that are there in the base class, those will be coming into this derived class, and derived class can have its own features. So this is called this extension. I can extend. Okay, I can reuse the existing features, and also I can extend these features. That is your extensibility. Okay, and data hiding. So base class can decide to keep some data private, so that it cannot be altered by the derived class. Okay, if that is done by using the visibility mode. If whatever the data that I don't want to inherit by the subclass, then I will kept in the private section in the base class. Okay, that is also possible. The data hiding also possible by using this uh, um, by using this inheritance concept. We can reuse the existing features, we can extend the features in the base derived class, and also we can derive we can means nothing but whatever the logic is there, for that logic also I can write some more code to I can extend. And data hiding. So if I don't want some of the features, like some of the data members or member functions, I don't want to get into the derived class, then I will make them as private. So that capability also there, data hiding also possible. Okay, and next, overriding. So with inheritance, one of the main advantage, one more advantage of this inheritance is I can do method overriding. So this that is runtime polymorphism. Okay, we will see that in this chapter. Okay, in the coming classes. So we have already discussed about the static polymorphism. So that is which method is called can be decided at the compile time itself. But that is possible through both function overloading and constructor overloading and operator overloading. But which function can be called will be decided at the runtime. That is done by using this method or that function overriding. Function overloading is same function name with different parameters, or same function name with same number of parameters but with the different data types. But in case of function override means nothing but already existing functionality is, that is I am overriding with new logic. Already some function is there, the same function without changing the data type, without changing the name of the function, without changing the parameters, I can write a different logic. That is for function overriding. So that function overriding is possible by using this inheritance concept only. That is runtime polymorphism. We will be able to override the methods of the base class in the meaningful, so that meaningful implementation of the base class method can be redesigned or designed in the derived class. So that is like if I have always this function overriding is achieved in case of inheritance only. Inheritance only. That's why this runtime polymorphism. Okay, function overriding is an example for the runtime polymorphism. This runtime polymorphism is achieved only in the inheritance. Okay, so if I have like this class, some base class is there. This is your base class. In this base class we have a method add. Next, so I am deriving a new class. So I am deriving a class D. So actually syntax is there. Just if I want to derive a class, then I have to use this syntax. We will see in the coming classes. So, but so what is the meaning of this one? Just D is a class that is derived from this base class. So that not yeah, this is a base class. So that whatever the variables that are there inside this base class and whatever the member functions that are defined inside the public section, okay, whatever the data members and member functions that are defined in the public section, those will be coming into this D class. So now D is called derived class and base is the base class. Okay, if this is also want to override the same function. Okay, so this is like this is add function with some logic like I am in base. Okay, so the same functionality, whatever the name of the function is there, that is your void function. Okay, so this is your void function and this is your name of the function and with some logic is there. The same function void and add with a different logic. I will write some other logic like a plus b. Okay, so the same function, whenever I am using the that is possible, this is called runtime polymorphism. The same function or function overriding, actually the same function void and what is the name of the function, add. So here also void and add. So the same function without changing the data type, without changing the name of the function and without changing the parameters, I am writing the same function whatever defined in the base class, that I am redefining with some different logic in the derived class. This is called I am overriding, because whatever the logic that is there, this will be replaced with this logic, that is called overriding. So this function overriding is possible in case of inheritance, that is possible through inheritance. Okay, and transitive nature of the inheritance, this is transitive property. I think you know in the normal in case of mathematics, you know, a to b and b to c, then I can directly say that a to c. Okay, I will erase and I will write neatly. 1 minute. Yeah. So what is this transitive nature is nothing but we have this A class. From this A class, I am deriving this B. So from this A, I am deriving C. So indirectly it is nothing but C is deriving this A class. Okay. So if B is derived from A and C is derived from B, indirectly I can say that whatever the properties that are there in A, that will be derived into this C. Okay. That is your transitive nature of the inheritance. If a class A inherits properties from another class B, okay, this one I think they define in different manner. So if B is a class and A is a class that is derived from B, then all the subclasses of A will be automatically inherit the properties of B. So that is your transitive property. So if from A, if you have any other classes, okay, like C, D, E, okay, indirectly, if A is a class, if class A inherits properties from the class B, okay, we have this class A. If this class A is inheriting from this class B, and whatever the subclasses of A, those will be indirectly automatically inherits the properties from the class B. That is your transitive nature. Okay, this property is called transitive nature of inheritance. This clarifies benefit with it. Suppose we inherit the class B from the existing class A. Okay, the class C and D inherit from this B. So they define in another manner this one. So how they mentioned over here is, suppose we inherit the class B from A. So existing class is A, and from this class A I am deriving B. So generally we will use it to notate the inheritance in the this one. Okay, B arrow mark with A, though that meaning is like whatever the class is A, from this class A I am deriving this B, and the class C and D inherit from this class B. So if I take for example C and D, both are inherited from this class B. Later we find that class A has a bug error that must be corrected. So after correcting the bug in A, it automatically will be reflected across the classes that inherit from the A, both the classes C and D. This reduces the amount of efforts one would have done if each class inherited from A class was to be modified separately, a gifted benefit of being transitive. So what is the meaning of this one? So if from A, B is derived, and from this B, C, D, E, all the classes are derived. Indirectly, it is nothing but I can use all the properties from this A inside this classes C, D, E. Okay, so that is the transitive features. Transitive nature of the inheritance. Okay, so from A to B, B to C. Indirectly, it is nothing but C to A, or D to A, or E to A. So if any errors are there in this A, if I correct those errors in A, those will be directly I can see in the C. Those will be reflected on this C and D and E because of this transitive feature. No need to write those changes individually in the class B, in the C, and in the D and in E. Okay, so whatever the properties that are inherited by this class A, those will be easily coming to the class C, D, E directly. Okay, even even we are not deriving this class A, indirectly as B is deriving from A, and from this B I am deriving this C and D. Indirectly this C and D can be inherited from this A. Indirectly it means that is nothing but whatever the properties that are there in the A class, those I can reuse in the C, D, E classes. So if any changes I am doing in the class A, those will be reflected directly on this classes, even those are not deriving this A class. Indirectly those are deriving from this via this class B, so that those changes will be reflected on this C, D, E classes. That is called transitive nature. So these are the necessity of inheritance. One is the minimize the duplicate code, because we can share the common code among several subclasses. And the next one is make the application code more flexible to change, because classes that inherit from this common superclass can be used interchangeably. Okay, and the next one, reusability. This is one of the main advantage. I can reuse the code, existing code. Extensibility, even I can reuse the code, and also I can extend the code, extend new features also for the existing code. Okay, as that code is getting into the subclasses, I can extend those subclasses to some other extension. Okay, and data hide. Okay, this is done by using the visibility modes. Okay, we will discuss that in the coming classes. So what is if I don't want some of the data from the base class to be inherited by the subclasses, then I can mention those data in the private section, so that it cannot be derived for the derived classes. That is called I can provide hiding to the data for the base class. Okay, and overriding. This is also one of the main advantage of this inheritance. I can do function overriding by using this inheritance. Okay, and the next one is transitive nature. That is nothing but it is indirectly if class B is derived from A, and if C, D, E classes are derived from this classes subclasses, then the subclasses can also inherit the features from the base class indirectly. That is your transitive nature. Okay. And the next one is your advantages of inheritance. Just now we have discussed what is the necessity. Same thing, advantages. So the main advantages of inheritance is mostly we have this reusability, readability, and one more thing is extensibility also. Okay. So these are the extensibility. Okay. So the main advantages of this inheritance is we can reuse the existing code. We can that is easily to readable, easy to understand. Okay, easy to readable. No need of clumsy code, because I am just reusing that code. Okay, no need to write large number of code. It will reduce the code also by using this reusability. Okay, when child class inherits the properties and functionality of the parent class, whenever I mention properties, those are data members, and whenever I mention function, those are functions. Okay, so data members are member functions. Parent class, we need not to write the same code again in child class. That is your reusability. Okay, so I can reuse that data members directly. No need to again defining those data members. No need to write the functionality again. Okay, I can directly reuse those functions and data members inside the child class. This makes it easier to reuse the code, makes us write the less code, and the code becomes much more readable. Okay, so by using this, we have two advantages. One is I can reuse the code, and it makes the to write less code, so that the code will become more readable. So it will increase the reusability and readability, and also I can extend also some new features. Let's take the real type example to understand this. Let's assume that human is a class that has properties such as height, weight, color, and functionality such as eating, sleeping, dreaming, and working. Okay. There is a class called we will see with example. So there is a class. What is this class? What is the class? Name of the class human. Okay, human is a class, and he has different properties like int height is the property, weight is the property, color is the property, and he has some functions like wide, eating. Okay, next wide, sleeping is the functionality, and one more functionality wide, dream, you can dream, and wide, work. Okay, all these are the functionalities of this class. So now we want to create a male and female classes. These classes are different, but since both male and female are humans, they share some common properties and behaviors, so that they can inherit those properties and functionality from the human class, and rest can be written in their class separately. So if I want to define the class like class male, which is deriving from this human class, this is also deriving from this human class, and I want to define one more class like female class. Okay, female class also deriving from this human class only. Okay, so whenever I define these classes, that is nothing but male is a class that is derived from this human class. Okay, and female is a class that is deriving from this human class, so that whatever the properties of this class will be there for this male also and female also. Directly I can use H, W and C in the male class, and also I can use HWC in the female class also. I can use these methods also. Okay, directly I can use within the male class and female class. Okay, so if I am having this, so what is the advantage of this one? I can no need to write these data members and member functions inside this male class. Directly I can use. Okay, so that is the advantage of this one. No need to write separately. Okay, so the approach makes us write less code, as both the classes inherited separate properties and functions from the base class. Thus we no need to rewrite these all the functionalities. If this function contains 1000 lines of code, then no need to write that function inside this main class. I can directly reuse that code. Okay, and what is the relationship between this base class and derived class? Okay, so what is inheritance? Deriving a new class from existing class, or deriving the properties from the existing class to the new class, or creating a new class from existing class. I am creating a male class from this existing class called human class. That is your inheritance. So whatever the class that is derived, that is whatever the class from which we are deriving, this is called your base class or super class. Okay, super class or parent class. Okay, I can call like this. Okay, this is your base class or super class or parent class, and this male is your base. If I mention it as base class, then this is your derived class. If mention it as super class, then this is your subclass. If it is your parent class, then this is your child class. Okay, we can define in this manner. So human is the base class. So what is the definition for this inheritance? Deriving a new class from existing class is called inheritance. Also called as creating a new class from existing class is called inheritance. Deriving the properties from existing class to another class is called inheritance. Okay, so in case of C++ inheritance supported by derived classes, a derived class is like an ordinary class, except that it has definition is based on one or more existing class called base classes. Okay, so derived class also it is also another class only, but just like a class only, but it has to be derived from another base class. Okay, base class. A base class is a class in an object-oriented programming language from which other classes are derived. Okay, this is the base for everything. Okay, this is the base for every other class. Okay, so it is a base class is a class in which other classes are derived. The class which inherits the base class have all the members, okay, of the base, as well as it can have some additional data. In the object of this derived class, base class members also present. Okay, so whenever I am creating this object for this male, So how can I create this object for this male class? So directly I can create MELEM like this. So whenever I create this object for this male class, I can use all the data members by using this M. So that is nothing but m.h or m.eat, because these are defined in the private section, so I cannot access, but these are in the public section. So m.eat I can access, m.sleep, but those member functions are not there in the main. Just those will be coming by using this base class. Okay, so that is your thing. And derived class, a class that is created on the basis of an existing class is called derived class. Okay, so the class from which other classes are derived is class your base class or super class or parent class, and the class that is derived from this base class is known as your derived class or subclass or child class. The derived class inherits all the properties of the base class. The derived class can add new members or change base class members. Okay. So what are the differences between this base class and derived classes? So a class that helps to derive or create new classes. So base class is mainly used to create new classes. From this base class I can derive or I can create new classes. A class created or derived from an existing class is known as derived class. Already existing class is there. From this class I am creating or I am deriving a new class. That is your derived class. Also called as parent class or super class. If I call it as parent class, then I can call it as child class. If I call it as super class, then I can call it as subclass. If I call it as base class, then I can call it as derived class. Cannot inherit properties and methods of the derived class. Okay. So what is the meaning of this one? A is the base class and B is the subclass. So this is not possible in reverse. So what is the meaning of this one? B can access all the properties from the A, but A cannot access the properties from the derived class. Okay. Only thing is this B is a derived class. Only the direction is in this manner, so that A can access all the properties or B can access all the properties from the class A, but vice versa is not possible. Okay, can inherit all the properties and methods from the base class. And this is the main relationship between this base class and derived class. We have this base class. Inside this base class I have different features. What is the meaning of these features? It may be a data member or member function. Okay, we have this base class. Inside this base class we have different features. The first one is your feature A, and the next one is feature B, and the next one is feature C. Three features are there. First feature may be data member, and second feature may be data member, and third feature may be member function. Okay, but in the base class I have three features, and the derived class, what is the direction for this one? This is your derived class, which is deriving from this base class. So what arrow indicates that it is derived from. So what is the meaning of this one? Derived class is derived from this base class, so that indirectly this feature A, okay, so these are the this base class has these features. So this derived class is deriving from this base class. So indirectly it means that whatever the features that are there in this base class, those will be directly coming into the derived class. So this feature B will be coming, feature C will be coming. Okay, this may be some like int. Okay, this may be integer variable, this may be float variable. Okay, this may be float variable, and this is maybe a function void. Okay, void add function. Okay, all these function and data members will be coming into the derived class, and this derived class can have its own features, like it can define int C. Okay, it can define its own variables, it can member functions. Okay, so this is the relationship between base class and derived class. So always derived class is deriving from the base class, so that whatever the features that are there in the base class, those will be coming into the derived class, and derived class can define its own features, and whatever the features that are there in the base class, those will not be changed. Okay, so these are the relationship or difference between base class and derived class. Okay, so as per the above figure, a derived class can derive some selected properties or data members as well as member functions. Okay, a derived class can, whenever a derived class can select all the features or some of the selected features. If I don't want to make the some of the data to be derived into the derived class, then I will make the data into be kept, I will kept in the private section, so that private variables cannot be accessed by the derived class. So As per the above figure, a derived class can derive some selected properties like data members as well as member functions of its base classes. A derived class can itself be the base class of another derived class. The inheritance relationship between the classes of the program is called as hierarchy. Okay, this is called hierarchy. A derived class is also called a subclass. A derived class can also be called as subclass. Okay, because it becomes a subordinate of the base class in hierarchy. Similarly, a base class may also be called as superclass because it is a from it many other classes can be derived. It is like a superclass, so that from this superclass I can derive as many number of as classes, and the derived class is also called as subclass because it is a subordinate class. Okay. Next, deriving a new class from an existing one allows redefining a member function of the base class and also adding new members to the derived class. Okay. So what is the meaning of this one? Deriving a new class from existing one means I can redefine these member functions of base class and also I can add new members to the derived class. In other words, a derived class not only inherits all the properties of the base class but also has some refinements of its own. Okay, so derived class can also inherit the properties from the base class and also it can have its own refinements. Nothing but it can have its own features, extra features. The base class remain unchanged in the process. Okay, so this base class I cannot change the anything, whatever the features, anything I cannot change. But what I can do, I can use those features and I can redefine or I can change those features inside the derived class. I can I also change the member function inside this derived class. Okay, what is the definition for this member function that I can override in the derived class? It is also called as easier type of base class, but with more details added. Okay, so this class is a base class. I can mention it as derived class is a base class, but it has its own features. So that is called easier relationship. Okay, but with more details added. For this reason, the relationship between this derived class and base class is also called as easier relationship. Okay, this you can expect for a ESET point of view. Like whatever the class, that is, what is the relationship between this derived class and base class is easier relationship. I can directly mention like fruit is two-wheeler is a vehicle class, three-wheeler is a vehicle class, four-wheeler is a vehicle class. Okay, so easier relationship. Okay. And the next concept is what is the syntax for defining a derived class. Okay, a derived class consists of features of the base class and the features of its own. Okay, so derived class consists of features of the base class. So in the derived class I can write the features of the base class, or I cannot write, so directly those features will be inherited into the base class. And the general form of defining a derived class consists of the following components. So what is the syntax for creating a derived class from the existing base class? That is where it contains all these things. One is the first one is the class keyword class. It will contain class keyword, an identifier to specify the name of the derived class. And what is the name of the derived class? It is like the same thing, like how can you create a name of the class? The same thing will be applicable over here. So the first is the keyword class, and what is the name of the derived class, and we have this single colon. This is very important, don't confuse with the two colons. Where I am using these two colons, I am using these two colons in the as a scope resolution operator in case of whenever I want to define this member function outside the class. Whenever I want to define this member function outside the class, okay, at that time I will use this. If I want to define this eat function outside the class, then how I will define? That is, what is the return type? Void. And what is the name of the class? Human. Scope resolution operator. Okay, scope resolution operator. And what is the name of the function? Eat. So whenever I am defining this member function, this eat member function outside the class, then I will follow this syntax, that is class name scope resolution operator. But whenever I want to inherit the one class from other class, then I will use this syntax, that is your single colon. Okay, always single colon is used in case of inheritance. And what is the type of the derivation? Okay, this is very important. So we have different types of derivations like public derivation, private derivation, and protected derivation. These are also called as visibility modes. Okay, So whether I want to derive the subclass publicly, or whether I want to derive the derived class privately, or whether I want to derive the base class protectedly into the subclass. So what is the name of the base class? We already have this base class name, and what is the definition of this derived class? We will see that in detail. What is the general syntax? Okay, this is your class keyword. Okay, generally if I want to create a class, then I will use this class keyword, and after that what is the name of the derived class, and I will use this single colon operator for inheritance. Okay, single colon. Okay, so this is your single colon. This is your single colon, and this is your accessibility mode. Okay, or visibility mode, access specifier or visibility mode. This is very important. Okay, so whether I access specifiers we already discussed. We have three types of access specifier: public, private, protected. Okay, if I mention what I can mention over here is I can mention public or private or protected. Okay, protected. So these three I can mention over here. And what is the base class? Okay, so this is your class is the keyword, and what is the name of the derived class, and we have this semicolon, single colon. Okay, and not semicolon, single colon. And next one is what is the public access specifier, and what is the access specifier, public, private, protected, and base class. What is the meaning of this one? This is the class that is derived from this base class. I am deriving this derived class from the existing base class. Whether I am deriving publicly, or whether I am deriving privately, or whether I am deriving protected, that is mentioned by using this access specifier. So what is public derivation, what is private derivation, what is protected derivation, we will see in the next classes. And next one is what is this private. So they are not private. So these are the data members. I can define these data members and member functions inside the private section, or inside the public section, or inside the protected section, and every class is ended with this semicolon. Here where derived class, it specifies the name of the new class, that is derived class name, and base class, this is your existing class, and single colon, which is used to specify the which is derived from. So what is the meaning of the single colon is derived class is derived from this base class. Okay, so what is the meaning of this semicolon? This derived class is derived from this base class. Whether I am deriving publicly, privately, protectedly, decided by using this access specifier. Okay, so what are the important syntax for this one is class, what is the name of the class, and what is the access specifier, and what is the base class name. Okay, and the general class contains all the data members and member functions. This I can define inside the public section, or private section, or protected section. Okay, so these are the keywords. Derived class is name of the derived class, base class is name of the base class, and single colon is nothing but derived from, and this access specifier is used to specify the visibility mode. Whether if I mention it as public, then what are the data members and member functions I can access in the base class. If I mention it as private, what are the data members and member functions I can access in the subclass, derived class. Okay, that is about this one, and we will see some examples for this one. This is your class A, and inside this one we have in the public section, private section, and protected section. So this is your base class A. So inside the public section I have this public A and public function A, and in the private I have this private is the data member, and this is your member function. In the protected also I have this protected data member and protected member function. This is about your class A. Okay, this is your class A, which contain this is your base class. Okay, it contains public variables, private variables, and protected variables. And this is your class B. Okay, so this is your class B, and I can mention over here this is your derived class name B, and what is the name of the base class A, and I can mention over here visibility mode, whether I can derive privately or protectedly or publicly. That is defined by using this accessibility mode. If I mention it as private, then this class B is derived from this class A by privately. Okay, so what is the meaning of this one? This class B, derived class B, privately derived from this base class A. Okay, so base class A. So what is the meaning of this one? This class B, which is also called as derived class B, privately inherited from this base class A. And I am defining one more thing, class A, which contains public variables and private variables. Class C, public A. So what is the meaning of this one? So C is a class, another class, which is derived. This is also called as derived class. Derived class is C, publicly derived from the base class A. Okay, it is publicly derived from the base class A. In the same manner, we have another class A, public section, private section. I have class D, which is derived from this class A but protectedly. Okay, so this is your protectedly. Okay, so I can mention, I will define like this. So I can do different, what are the different ways? So that is, what is the keyword for this class? Class A. This is your base class. Okay, so this is your base class. This base class, I can take one example like int A comma B. These are in the private section, because if I didn't specify anything, those are by default in the private section. I have this void add is the function. Okay, so void add is the function. So this is your class A. Inside this class we have this private variables, and this is your member function that is defined inside the public section. So I want to define a class, I want to derive a new class B from this base class. Okay, so base class A. So this is the syntax for this one. Okay, so that all these private members and public members will be coming into the base class. So but private data cannot be inherited into the derived class. That we will see in the visibility modes. Okay, in the next class. Okay, but only these public members can be, or public and private protected members can be, I can inherit into the derived class. So this is your, what is the syntax for derived class? First one is the name of class is the keyword, and what is the name of the derived class? B. And I have to use the single colon operator, which is the, what is the meaning of the single colon? I am deriving from another class, that is your base class. Here base class is your A. So this is your base class. So here in between this derived class colon and your base class, I have to mention the access specifier. This I can specify either public, or I can specify private, or I can specify protected. Okay, I can specify public or private or protected. So if I mention it as public, then I can say it as B is a derived class that is derived publicly from the base class A. Or if I mention it as private, then B is a derived class that is privately inherited from the class A. Or if I mention it as protected, then B is a subclass, or B is a derived class that is derived protectedly from the class base class A. Okay, so that the data members that are there inside this class A, those will be coming into this one, so that I can easily create the object for this base class. No need to create the object for the base class. I can directly create the object for this derived class like B obj, and so that I can easily access this add method. So no need to define this method inside this class B. Even this add method is a, add is a function that is of belongs to this class A. I can use by using this class B, because by I am inheriting this class. Even if I derive by using private or public or protected, I can use these classes inside this derived class. Okay, this is about today's class. So in the today's class, what are the topics that I discussed are, so what is the meaning of inheritance? Okay, so inheritance is nothing but the process of deriving a new class from existing class, or the process of creating a new class from existing class, or the process of inheriting the properties from the base class into the derived class. And after that we discussed about what is the necessity or advantages of inheritance. We can say what is the necessity. We have different things, that is we can easily derive this. One of the key benefits is like we can minimize the duplicate code, and we can also make the application code more flexible, reusable. I can reuse the existing code, I can extend the features, I can data hide, or I can override, with the function overriding or transitive nature. All these are the necessity and advantages. Main advantages are reusable. I can reuse the existing features, which will increase the readability, and also I can extensibility. Okay, I can extend the features. And what is the relationship between this base class and derived class is, we have this base class, and from this base class I am deriving the another class called derived class, so that whatever the features that are there in the base class, those will be derived into this derived class. And derived class can have its own features. Okay, if I have two features, this three features will be derived into this one, and it can have its own features, extra features. Okay, if I have these three features from the base class A, I am deriving this class B. So from this base class A, all the features can be derived into the class B, and this B class can have its own features. I can extend the features. This is called extensibility, and this is the relationship between. And also this is also called as easier relationship, because B is a A. Okay, B is a A, and also the whatever the classes that are there in this whatever the features that are there in this base class cannot be changed, and this is only one direction, that is B can access all the features from the A, but A cannot access all the features from the B. This is the relationship between. And what is the syntax for this one? Just class is the keyword, and what is the name of the derived class, and you have to use single colon. Here you have to use accessibility mode, and what is the class that I am deriving? A. So this is the syntax for class is the keyword. This is your derived class name, and you have to use this single colon. Don't confuse. Whenever I am defining the member function outside the class, I have to use scope resolution operator. But whenever I am defining this member function, whenever I am using this inheritance, this I have to use single colon operator. Here I have to mention the accessibility mode. We have different access specifiers: public, private, and protected. Okay, so if I mention it as public, I can publicly derive this base class, protectedly derive this base class, or privately derive this base class. So in the next class we will see the remaining topics, like what is access specifier. So with this I am concluding the today's class. Thank you.